You are 100% right. Thank you so much. Well, well, that's embarrassing. You should be able to hear me now. I had a big mute turned on. Hello, Sir Cruck. Thank you for the feedback on the no sound issue. I'm going to just keep my eye on chat here for a second to see that loud and clear. Okay. So let me start again then. Um, this is the second series following on after my FANG interview prep course, or the tech interview prep course, as we sort of renamed it as we were going on. So this was the first one. It was a 14-week series on um, how to prepare for a coding interview. And there was a lot of, you see, I did week 0 and then there were 13 total, so it's like, because we're programmers, we have a zero based array. I thought that was clever. It made it really hard in the long run, so I think I'll do one based from now on. Anyways, so um, that was the first series. It went pretty well. At least one of the people who came in week after week wound up getting a job by the end of the course. I got a job by like the third week or something. So it was amazing. Um, if you uh, and these are all stored on YouTube, so you can go back and watch them with the repo and sort of follow along. So that's all just sitting there ready for you to use at your own pace anytime that you like. And this second series, the Clean Architecture Book Club, is intended to go through this one, the famous Clean Architecture, published in 2016. This book is about software design. How do you prevent, or I mean, how do you build software systems more more than just writing your algorithms, right? This is more. This is how do you structure your code in a way that helps you long term with complexity, with larger teams, and things like that. Now, I do have a 2 hour time block set aside, but I'm not necessarily worried about filling the entire time block. So this week is a particularly light reading week. It's about just sort of getting geared up, maybe showing you a few places where you can get the book. So this is this is the book. You can get it directly from O'Reilly. If you want to go on to Amazon, you can get it on Amazon. Clean Coder Audio, Clean Coder Audio.com, I think. The worst. Anyways, I could have done a better job of getting those links together for you. We are, anyways, we're not, oh, here it is. Clean Code, it's Clean Code Audio. Um, so this one is kind of a great site. It looks like you're buying it directly from the author. And if you buy the 4-in-1 package, you get all four of his books for $60 US, which is a really good value. Those are the audiobook. You can get the print edition. Or, based on the way that I'm doing this, let's be honest, like with any book club, there's the chance that you show up having not read the chapters that were assigned for the week. My hope is that week after week, I give you enough that you could proceed through the whole thing without purchasing the book. It's up to you what you do from there. I'm also going to be referencing a couple of other really important books in the engineering space that I happen to have. This one is Staff Engineer Leadership Beyond the Management Track. That's by a fellow named Will Larson. We'll go in and reference parts of that, but mostly with a focus on architecture. And the final one that I think is super, super relevant that I happen to have on hand is this one called A Philosophy of Software Design. So I will be referencing these books throughout the series, trying to tie them all together. But for the most part, the expectation is that we will go through and read this book, 400 odd pages, for the next 14 weeks as assigned, or just tune in for my notes. Now, feel free to ask questions in chat if that's if you come up with any. It's going to go a lot faster. Going to go a lot faster if nobody else is talking, but that's fine. I'm here for it either way. So the first thing I'll talk about is the way that I'm using this both here on YouTube and with my current employer, Zensurance. So we've started a proper book club at work. So we'll be reading the chapters on the same schedule. I'm actually a week ahead of, so next week we're going to have our discussion on chapters 1 and 2. And what's really interesting and fun, I think, about the way that we're going to do the discussion on the internal at work version is we're going to compare the things that Uncle Bob, Rob Martin, talks about in the book and apply it to our own code base. So we're going to ask questions like, how does this apply to our work, our code base at Zensurance? How are the ways that we can improve based on the rules that he's presenting, or things like that? And I think the most exciting part of having it's voluntary, but we're getting all staff from first year, fresh out of school developers all the way up to people who have been programming for longer than me. So what's really going to be interesting about doing that and having these sort of open discussions is we're going to be able to get a breadth and diversity of opinions and really good feedback from the newest developer up until highly experienced developers. And I think it will turn into a very collaborative space, hopefully, where we all own the code base. And so that's a bit of a suggestion that I will be reporting on as the weeks go along. But also, if you think that's good, maybe you raise that at your own workplace. A special call out to edX, Open edX. If you look at this, is the actual schedule that I stole the content from. So this is the same schedule, and they even have their own notes here, so we can go through those. If there's anything else, or any questions or anything we want to talk about, otherwise I'll just hop right into everything that I've got from week 1 and 2. So the chapters that I read off the start were the table of contents. I'm not going to focus in on that. That would be way too tiny. The table of contents, the foreword, the preface, the introduction, chapter 1 and chapter 2. So, and I'll just try and summarize what's coming out of the book, and we can talk about what we like and what we don't like. So the book itself, from my notes here, and I apologize for this, I kind of want to set this up going forward so it's like a PowerPoint more, so we can go through a slide or two at a time, but I ran out of time on this, and per the name of the channel, ship it. Like, I'm not going to delay. If I don't get to the point where it's good enough, then we go with what I got. So that's my That's the theory. So I should be doing better for you, but I in this case did not, and I acknowledge it. So I hope that you're okay with that, and I hope you forgive me. So here we are. So the book itself is divided into six main sections. Now it is 400 pages. Each of the sections is further subdivided. So it turns out I am going to zoom in on the table of contents here a little. So when I say main sections, like you can see there are a lot of chapters that are going on there, but there are six broad themes throughout the book, and so you've got five chapters in any given one of these sections. So in the introduction, the bit that we're talking about today, Rob Martin defines software architecture. He sort of lays the case for what I mean by lays the case for the work. He makes his arguments around. Oh, who's this? I love the name of your channel. I use every day. That's right. We just ship it. We just ship it. Looks good. Ship it. Thank you very much, Sir Krug. So in the first section, he sort of lays the case for his work, meaning he makes the argument around why we should give a damn about architecture and what's important about it. Then he moves into programming paradigms, which is a historical look at these three main types of programming that we can have. We can have what's called structured programming, which I think you would find in early PHP or something like that, where you've just got the function or you've just got your flow and your code runs from top to bottom, and it's structured programming. Functional programming, he goes into detail, and mostly I would imagine most of us have a more deeper understanding and more familiarity with object-oriented programming. But we look at those paradigms throughout the book and go into detail about why they matter and why they're important. Next up in the series, there is solid principles, which is an acronym, which each letter is sort of, the S is single responsibility principle, meaning your classes or your code should only do one thing. And the D is for the dependency inversion principle. So that's about dependency injection and how do we further decouple our code in the long run. But again, these are for future weeks. This is just to get you ready for the themes that are coming along. The component principles, I will admit that I have not read yet, which is fine because we're going to read them together. But the components, I guess, is Rob Martin talking about how we go from there's a really interesting part later on. Well, components are sort of, if we're following the metaphor of architecture, the components are the bricks, and then the way that we stack our bricks together becomes the picture of the architecture. And from there, we talk about architecture in the broader sense, and then finally we delve into details, where I found this was really interesting because some of these chapter titles, let me read you some of these chapter titles. His chapter titles are, here's one, the database is a detail, okay? The web is a detail. Frameworks that you use are details. And what's really important to acknowledge about that is the perspective of this book is not to delve into the difference between React or Angular, or whether .NET Core is a better choice than I don't know, Python, or whether TensorFlow matters, or how do microservices or how does the architecture of distributed computing apply to what we do? And all of that is really interesting, but all of that is the detail. Whether you choose MongoDB or Postgres or SQL Server, that's a detail, and that does not have an impact on the rules of architecture. So that's a really those, and it's critical that we know these things, but it's also critical, or it's also helpful for us to be able to separate those individual specific decisions from the big picture, the structure of architecture. So that's that's the timeline of the whole series as to what we can expect over the next 14 weeks. For now, we're just going to talk about this is basically the introduction is happening now. So we have the foreword, preface, introduction, chapter 1 and 2. In the first part, in the foreword, Uncle Bob or Robert Martin describes architecture as a metaphor for the structure of code. And so I don't know about what your growth trajectory looked like as a developer, but I started in the late 90s, and it was always so mystical sounding to me that one of the developers up the line of cubicles was considered a technical architect, and I had no idea what that meant at the time, and I still, to some extent, don't always have always have the best sense of what that means. It can mean different things in different places, but it's important from this perspective to realize that architecture in a coding context refers to it's just a metaphor. It is not anything real. It is a synonym for software system design. It's how we put things together. There was an interesting line in there where he says, if you compare a bricks and mortar type building of architecture, software is very different because software is made out of other software. The programs we write on if we write a desktop program in C#, that's made out of the C# compiler, which compiles down to machine code, and each step along that chain, each piece along the way that we're working with is software made out of software made out of software. When you get all the way down to the C compilers and things at that level, it is, even the C compiler will convert, is software that converts things into machine code, which is the lowest level of software that we can get to. So I thought that was a really interesting phrase in the foreword. It's fractally complex. The deeper you go, the more complex that it gets. So we typically work at a much higher level in things like JavaScript and PHP, C#. Actually, Sir Kruk and Hussein Webb, I see that you're here as well. Feel free to let me know what languages you work in, or what domain you work in. Are you embedded programming? Are you web programming? Sort of let me know a little bit more about yourself so I can tune the level of my content and discussion. So what's the next line there? Architecture represents. So this was a really interesting point as well. So architecture is not it's not the little stuff. Architecture isn't tabs or spaces. It's not you put a new line here. It's not whether you put your curly braces on the next line down or what you do. Architecture represents these significant decisions. So the things that really matter in your software system design, where, and that's a typo there, where it's a measure of the cost to change your program, the as opposed to anything else. There's things that are trivial that we don't have to worry about, that we can work through from a pragmatic point of view, whereas there are things that are expensive decisions. And so architecture is about getting your handle on the expensive decisions and trying to look ahead to plan for the expensive decisions. So there's another great quote: if you think good architecture is expensive, try working with bad architecture. And let me double check if that was in the forward. No, it's chapter 1 we get into costing analysis. So we'll hold on for this. Okay, mostly web programming, but familiar with different paradigms. Mostly use PHP and Python today. Written code in x86 ASM, C, C++, C Sharp, JavaScript, web technologies in general, of course, VB, maybe other things, practicing Golang, Rust, and Dart. Holy man, oh man, that's awesome. Well, thank you so much for stopping by. That's really cool. So that's really cool. Okay. And there was one: how do we reduce future development costs without knowing what's going to, yeah, right? Like a person of many, many, many talents. That's really great. So the within the forward, the number one question that he asks right there, that we really present, is how do we reduce the cost of development if we don't know what's going to happen, right? You've got to think about this in the case of you've got your non-technical audience who says we need our program to do this thing, and then you do this thing, you do the thing, you implement the button that when you click it, it gives you an answer, and Sir Kruk is a Java player, understands all language. Yeah, I agree. So, and then if you've developed this button that you click it and it does something, right? And the non-technical person who you're working in collaboration with suddenly says, "Oh, I had no idea that the world was this easy. Well, can we add this other thing?" And with good architecture, in theory, if we've planned ahead in terms of making things, I'm not going to say scalable because that means something else, but from a design perspective, in terms of scalability, can we reduce future development costs when we don't know what that thing they're going to come back and ask us is, right? So this is, how do we decouple things? How do we make stuff? Uncle Bob's experience at the point in time of writing the book had to do with 50 years of writing code. So when he started writing the book, he gave a long list. The list he gave was almost as long as Hussein Webb, if I'm honest. Which is still really, that's awesome. That's so cool. So he said, I've been doing this for 50 years. I've written desktop apps, console apps, web apps, and the one thing that time and again comes back from his point of view was that the rules for good architecture are the same across the projects, no matter what you do. So if you are doing microservices, if you're doing distributed computing, if you're doing a standalone web app, if you're doing, I don't know, a set-top device, almost. I don't know. Well, I've been doing it for 20 years, so I've worked on a handful of languages as well. That's not. No, I was teasing it. I'm happy you're here. That's and that sounds really fun. I'd love to hear more about it. So, and then within the introduction, it says when software design is done right, it takes a fraction of the human resources and time to do it. So there's and here he says, so we're into chapter 1. We're talking about what design and architecture is, and it's important to note that realistically architecture and design are the same thing. They're synonyms, and that should help, I hope, to demystify the thing. This is not the matrix where we had the architect in the matrix. We're not mystical beings who sort of sit around in our TV screen rooms with white suits on. It's one of the things, and I don't know where I saw it. I don't know if it was in this chapter, but one of the things that was really important to note is the architect, the technical architect, is a hands-on coder. I think that's in chapter 15 or something. So, but the architect is not separate from the code. The architect should be writing code every single day, and should be at the lowest level of in a position where they can also understand the pain points of the developers on their team. So you've really got to be in there if you want to deal with system design. You can't, according to Uncle Bob, you can't be separate from it. There can't be a team of standalone architects who just dictate system design. They've got to be in the system to design it, so they know where the things are that are going wrong and going right and whatever. But that's an important point in the book. So the goal, I wrote that twice, so that's fine. The goal is to minimize the human resources required to build the system. That's different from how it's defined in the Mythical Man Month. It's good to be... Yeah, so I have not read the Mythical Man Month, so I don't know that, but that's a really great insight, so thank you for sharing that. So does that mean... That means that in the Mythical Man Month, they're under the impression that it's a good idea to have somebody outside of the code telling everybody else how to structure it, but then to leave the people writing it to just flounder? Anyways, so then he goes into actually, this is great. So Fong Tu is a TikTok, yeah, so 70s, they might not have known the rules as quite as well. So I'll talk about the case study, and then we'll watch Fong's TikTok video, which is really, really useful in illustrating what's going on. So there are some graphs. So here's the first graph. Market-leading product software lifecycle. The number of developers are on one. I mean, software development looked a lot different then. Agile simply wasn't possible until modern. Yeah, that's probably fair too. So here's this first graph, which is sort of it's a made-up graph that talks about the number. You can see the number of developers on the team as the release cycles go on, and it's quite clearly an exponential graph that you say as time goes on, in order to scale the project, you have to add developers to keep going on the production. And so these are, just over time, you're adding developers, right? Then here is another, this is all made up case study, and we're measuring in this one software productivity by lines of code. Oh, I've got to go now. We'll watch the rest on YouTube. We'll try and catch this live. Thank you so much for coming. Yeah, I really appreciate you coming. I really appreciate you chatting. Thank you. I'm just going to keep going because I've done all the notes. And so, yeah, you can watch it back later. You can tell all your friends to watch it later. But thank you for coming around. So I'm going to keep going. And so what you see here, and this is, we all agree kind of that lines of code is a terrible measure, but what you're seeing on that second graph is if you overload, so the first one is as you're getting more developers, you've got that hockey stick going up for the number of developers on the team. Now, what's interesting is in that second graph, you're seeing the productivity start to level off, right? And so we'll zoom back in on that where it's right here. You've got your productivity levels off. And so a solo developers, and so and that's Mythical Man Month as well. Adding more developers does not increase productivity necessarily. So it goes up like this, right? But here's the next one again, or the last one right there. If you look at this one, this is a graph of your salary costs. So the number of developers you have goes up. Your salary costs go up, but your productivity plateaus. And that's his argument for why we have to pay attention to architecture, because the better our architecture is, the cheaper it is over time for developers to operate in a way that is as if they were solo developers. It's handling complexity. Once your complexity goes out of control, that's where you start to have trouble. One of the things that I'll reference from the philosophy of software design is chapter 2 in this book is all about the nature of complexity as well. So this is, there are multiple examples. In fact, the staff engineer as well talks about managing complexity, and so in a different context. But it's important to note, and I'm saying too much, so I apologize. I've got to work on that. I'm excited about this new section. It's important to note that complexity is widely agreed to be a problem. So Fong Tu, I used to work with him a few years ago, and he has been blowing up on TikTok lately. And this video here talks about why does complexity happen as your project scales. So we should watch this. So
but let's get into why software is hard.
Let me see. Here we go. Can I zoom this up to full size? No? Okay. Anyways, let's play. This is, and feel free to, oh, I'm not logged in, but feel free to follow. Anyways, the link is on there, so we're going to watch this.
Had to deal with this guy for the last few days, but let's get into why software is hard. And it's not the code. The code is arguably one of the easier parts of the job.
Say you're a solo dev and you're just building out an API for whoever. You have your routes over here, your controllers over here, and your methods or functions over here that's going to call. Your controller controls the flow. Your business logic remains within each of these individual functions. There's an interface here, so these two are in agreement and there's no discrepancy. So let's say a second developer joins. Now you have to do a README, or you handhold that person to onboard. Then you also have your Git process, right? You had this before for yourself, but this is the process that you're gonna have to develop for the rest of the team. Now, you and this other developer are just kind of like working together, having a very close conversation, and things are getting done. Let's add a couple more developers. With a larger team, you now have a planning process. People usually follow Agile, and then you have siloing, which means your developers have a specific domain knowledge on some particular area. Now, to solve siloing, you're gonna need to have documentation, but we all know that documentation is probably one of the hardest parts of a project because no one ever wants to do it and is always done last. Cool, now let's say your API gets a little bit mature, you want to do some data retention. Now, add a DB of some sort, add an ORM of some sort. Now, let's say this developer is gone, right? Went to another different job, only cared about the money, something like that, okay? This person did not do any documentation, did not do any communication, and now you lose this amount of knowledge and someone else has to pick up the pace. Cool, so let's add another team that's actually using your APIs. They start to use it, everything's great, and then all of a sudden, someone makes a change and it breaks production. You do some debugging and then you realize you need to add some more information, so you add some logging, and then you realize you need to figure out if there are any errors early before anyone else sees it, so you add some monitoring. You have to make sure things don't happen again in the future, so you add some postmortems into the process, and then you also add more tests. Now, your service is getting popular, so the traffic goes up, so you realize you have to scale a little bit. Now you have to involve the DevOps or infra team to help you with that. Or you do it yourself. Meanwhile, your client teams also multiply, and they're asking you if you can implement more features. Meanwhile, that problem that killed production earlier, you're still trying to debug it, but you can't because there's so much tech debt in the way. You might be asking, how did that bug get to production? Why weren't there reviews done? Why weren't there tests written? There were. There was just less than 100% coverage. And everyone is drowning, so they don't have time to do a proper review. Then you try to consolidate a lot of the opinions in the reviews and come up with a style guide. Meanwhile, that one problem is still happening, and so your PM, your business people, and your VP are angry, and they're asking you what's going on. So then to make sure you don't go to production or you detect things early and fix things early, you add on-call. Then the government's coming at you, so you have to start doing privacy stuff. You're expending a bit more, so then you have to start doing internationalization, which means you have to work with translation teams. Multiply that by a couple of teams who you have to interface with, and it's harder for you to move quickly because now you're monolithic. Now you have to break it into microservices, but people are arguing about what to use. Meanwhile, all this is happening.
And there's also a bunch of other stuff. Anyway, hope that was informative. Follow-up. Had to deal with this guy for the last few days.
There we go. So I really like that one. And he actually exploded a little on the internet. He was retweeted by David Fowler, and a handful of other very well-respected programmers out in the industry. So good for him. That was pretty exciting for everybody involved. Okay, so here we go. So we see what that sort of spaghetti ball of crazy features. Oh no, my camera's back. I don't know what happened there. Little jiggle wire there. Okay. When little or no thought is given to the cleanliness of the code or the structure of the design, the development speed slows to a stop because of the complexity. And if you were looking at something like that video from Fong, you can see very well you can see where all of this thing happens. As the team expands, people have to come in and learn the lines of code. So the point of all of this is to say, well-designed code really matters. You can come in and have someone say, well, look, we'll do this right now. We'll just clean it up later. Don't worry about it. But the reality is you almost never really actually do, right? So once it's working, I think the business teams are going to say, well, that's fine. Who cares? Just keep going. So don't skimp on this. Don't when there's something that you know will be a problem over time, deal with it cleanly, do it right the first time, because making a mess is always slower than staying clean at the start. So this is sort of a spot where I thought there was a great discussion question available to us where we say, is that really true? Is it really the case that that you should never make these compromises? And I don't think that's true. And I also don't think that's what Uncle Bob is saying. I think we have to really deal with all of this pragmatically. We've got to think about the needs of the business. If you are a startup with very little funding and a burn rate that says you've got 6 months to get your product to market or you're going to turn the lights out, then of course you compromise. And of course you deal with it later. And, if you've got this idea for deploying something with artificial intelligence, you take shortcuts when you're getting started. The question is, are you willing to take on is the business willing to take on the costs of the problems of the tech debt that you're building in right then and there? So But it's a case to say that even with where I am right now, throw it out. And where I've been for the last 10 years, we never did throw it out and start over, because nobody wants to pay to rebuild something from scratch. Additionally, you come in and you've got this sort of, and I've had this problem, I've done this problem, where you have what is effectively overconfidence around the decision to say, this is a mess, throw it all out and start over again. But the reality is, it's really easy to say, this piece is a mess, but code is often quite like an iceberg, where there's this tiny bit that you've got your eyes on, and you can't hold the rest of it in your head. It's all of this, 90% of the iceberg is under the ice. And so if you throw it out to try and start over, you may find yourself saying, oh, I forgot about that little piece of complexity, which turns into a rabbit hole of changes that have to be made. And you find yourself in the spot where you're making these compromises all over again, because you had this estimation process, you had this budget that you set aside to work on this, and then you forgot that massive piece of functionality, and you're back where you started. So much like Kulaiti. So there's another typo for y'all. So, but the argument is that the best option, the single best option, is to take quality seriously from the start. We'll find later in the book that quality gets defined further, and we get operationalization in terms of our definition and specific things that we can do to handle that. And then on a long term, the rules of architecture allow us to minimize our effort and maximize our productivity. And I wrote interfaces here because interfaces are these things, these code structures, where instead of writing all of the content for your code, you just write a list of the functions of the code. And that can feel, for a lot of developers, like needless boilerplate work. And the thing is that if you use interfaces, that bit that I'm saying about the stuff that you don't see, the stuff you don't see because it's below the iceberg, well, your interface has the definition of everything that you actually have to do, every part of that contract that you have to fulfill. So if you've got an interface, the stuff below the iceberg doesn't matter anymore, because you've got your list of things that are critical. Now, what does that mean for minimizing effort and maximizing productivity? Well, interfaces from that perspective become a long-term investment in your project, because it's a lot of extra boilerplate at the start of your development. That is, yes, Sir Cruck, that is absolutely dependency inversion. And so I left that part out. So what you do is, if you have a dependency in your class, you pass an object that conforms to the interface's contract. And it doesn't matter what version of the interface you pass in, as long as it fulfills the contract of the interface. Now, what that means is, I often use these for persistence layers. Okay, so I've got myself a database, and maybe I'm using MySQL, maybe I'm using Postgres, maybe I'm using MongoDB. But if I write an interface that says, I've got a function save, and I've got a function delete, and I've got a function update. Well, it doesn't matter what exact database is behind that interface, right? So that's where, and so I pass in an object that conforms to my interface. But if I want to switch from Postgres to Mongo, from Mongo to Cassandra or Cockroach, I just write a thing that uses my interface, and it doesn't matter exactly what the differences are between the way that Mongo saves something or the way that Cassandra saves something or the way that Cockroach or Postgres, because it's all just going through my, I mean, you could call it like a middleware, right? But I mean, it is an interface, but I'm just trying to find other metaphors that work. And so, yes, that is exactly dependency inversion. But I often see, and this is the point of the interfaces thing, I have had numerous conversations where I've had to defend the interface. People don't understand them all the time, or the people who don't understand them, but that's a tautology. So if you are a newer developer, it is a likely case that what you see when you're asked to write an interface is extra code that doesn't do anything, and it's a waste of my time. It's just boilerplate, copy and paste, stupid stuff. But they're an investment in the long-term quality and structure of your code. And so have reverence for the noble interface. It is a powerful tool. And that's that. That's the first chapter. And what's this? I'm all interfaces too. I found they're the best. Yeah. And for documentation, because it does this, it does this, it does this. And exactly. So, but have you also had the argument about whether interfaces are worth your time? I mean, I've seen I think I've seen principal engineers at Microsoft on Twitter. Yep, they help you name your ideas. They help you name what you're coding and how it works. Yeah, well, I've seen like principal engineers at Microsoft who have complained about interfaces not being necessary, and so I think it's in a very narrow case. He had a point, but so they get a bad rap, but it's again an investment in the long-term quality and stability of your project. So in the next portion of the book, Tale of Two Values, Robert Martin, oh, by the way, how that's related to inversion of control, never managed to grasp the subtleties here. So that's a really interesting question. So the if you've got a class like a no, that's fine. No, absolutely. This is about coming together. It's about coming together, and it's about the social time, and I do block out 2 hours for it. So I absolutely prefer the interaction, and if it was more than just the two of us, or if Hussein Webb was still around, then more of us could be chatting, and it would be don't apologize for asking questions or having a discussion. So the inversion of control thing is, you might have at a higher level, I might have an MVC program, right? So I've got my web controller sitting out in front of the in the front of the program. That's what our clients or web users, our users will interact directly with a controller. Well, if within our controller we want to save some information, so they send a form post to us, so they save information they send information into our controller, and we want to store the information from that form in a database, there are two ways to do it. We can write our controller so that it knows connect to a Postgres database, save the record in this format, do all of these things. And you are tightly coupled in that one controller to the exact type of database that they've meant that you're working with. Well, another way to do that same thing is to write an interface, and using some commands in your application startup, you would tell your application startup that when I am asked for an object of the type database persistence layer interface, or an iDatabase persistence, use this exact kind. Okay, so, and by the exact kind, we would say you would have custom written something that conforms to the interface called a Postgres database interface layer. And that would be code that you wrote, but you're telling your program to use that exact type. And so when your controller gets built, there's a constructor, right? When you build any object, there's a constructor, and the constructor comes with parameters. The parameters would be pass in as a parameter on my constructor for my controller the type of database that I'm using. So what that means is the database layer is outside of your controller, and you send it into your controller, and you use that thing that you've passed in to save the data to the database. Now that means when you get to the case of writing unit tests, when you decide you need to upgrade and change your database, all of those other things, you can just pass in a different type of database layer, right? So you wind up separating. This is called separation of concerns sometimes. Your database gets passed in so you can use it within the context of the controller, and it's not your controller connecting directly to any individual type of database. I hope that was clear enough for. I wasn't expecting that. I would bring up some samples if I had them handy, and it used to be that I would have hours of video also queued up, so that like there were points in the show where we would watch and I could do some Googling and pull up your stuff. But I hope that's okay. The dependency inversion of control, or dependency injection. It's basically you're saying the controller depends on its ability to connect to a database. And so rather than connecting to the database internally, you inject the database, right? So you inject it when you pass in the value to the constructor at build time. So I hope that was clear. That was, and let it turn over a few times. And you know what? If you're here next week and you still don't get it, we can go through it again. But actually, come to think of it, let me tell you which week we are absolutely going. So the dependency inversion principle is chapter 11. So if I can tell you what week exactly. Week 4, we have a deep dive. Injection is, yes, exactly right. Injection is an example of inversion of control. Yes, that's fact. That's right. So, I was angry at the guy who first taught me about it. I thought, why are we doing this? This is so hard. I don't get it. For an entire project almost. I thought, what am I doing? I don't know what's going on. And then suddenly we had to change a component, and I said, oh, I get it now. This has changed everything. it is complex, but if you're working with .NET, oh, you said you're a Java programmer. Yeah, if you're working with .NET Core, the newest version of the framework is dependency injected by default. So, um, yeah. Well, yeah. No, for sure, for sure. So, anyways, let's get back to here. The chapter is a tale of two values, and the by feeling the pain. Yeah, that's right. By feeling the pain. The two values in software that are at odds with each other, well, not at odds, but the two major things of value is behavior versus structure. The behavior is what the business managers tell you to make the computer do. So when I click the button, it opens an Excel spreadsheet is a behavior. When I click the button in the Excel spreadsheet, it uploads the information from the spreadsheet into the database. That's the behavior. The structure is how difficult is it to change the behavior when they say we need it to do something else. When we need to alter the numbers before they arrive in the database. We need to store them in a calculated format. So there's a new feature. You've got to worry about how to do that. Sometimes it's hard, sometimes it's easy, and those are the two. I mean, the two poles. It's the two poles of what we have to work for. So this isn't exactly what he said, but I thought it was cute. You go, software. The reason they call it software is because it can change, right? It would be hardware if it was the chip itself, right? If it was the physical manifestation of the technology, that would be the hardware. It's the box, the chip, whatever. The software is the instruction set, and the instruction set must be changeable. And that's where the term software comes from. So it's important to think about that in terms of, software. It's soft. It has to change. And that's so when stakeholders change their minds about what they want, and these are your business people who come in and say, we need a different report. We need, it's amazing to me because the power of software is such that the non-technical people that we support and that we do our things for sometimes don't even know the full scope of what's possible until we show them a little taste. So of course they're going to come back time and time again and say, I had no idea that this was even possible. Could you also do this? And we go, oh yeah, that'd be really hard though. So it's the change is constant, the change is important, and the change is actually a sign that we've done a really great job because we've expanded the limits of their imaginations and we've expanded what they even think they could ask for, right? When something happens, when we do something in software that they didn't think was possible before, they said, I didn't even think I deserved that level of ease in my life, right? This is we do really magical stuff sometimes. So the reason that the costs grow out of proportion to the size of the request. So you have to think about a project that you've written. I'll say I've got a website. That takes a form request. So someone submits a form and it sends information into a database. And one might think that if they say, oh, we weren't capturing state or phone number, and we need to start capturing phone number, you would think that that's probably like one or two lines of code, right? That sounds like an easy fix from a business manager's perspective. Well, if we've been programming for long enough, we've all been in the case where something that sounds easy is incredibly difficult. And that's the case that we're talking about there. It's if you have something that is poorly structured, and one of the things I'm realizing right now is I should have more real world examples of projects where this has happened, but hopefully you've experienced this where they say, "Oh, this is a really hard thing." So it's the structure. So behavior is often urgent. So things can fall into four categories. It's either important and urgent, or unimportant and not urgent, and there are two other conditions that are a mix of that. And so the behavior, the thing that it does when you click the button or you move your mouse or whatever, the behavior is often urgent, but it's not necessarily important all the time. And in my discussion questions, is that always true? Isn't the thing that the client is asking for always important? And I don't know, maybe there are some times where a calculation can be done manually after the fact and it isn't that important. But architecture is always important. Architecture always matters for the long-term life of the project, but it is not always classed as urgent, especially when somebody is saying, "I need this in my hands tomorrow. I need this now. Production is down right now." That's urgent, but it is, and if you have to compromise on architecture to get your live website back up or your production program back up, then you've got to do it, right? So architecture is always important, but sometimes it has to take a bit back seat. Now, here's another thing. Here's another thing that was interesting from this. The business managers or the product manager team or the project manager team are not always in a position where they can evaluate the importance of the structure. So they would be saying, like, they sometimes don't know. They say this is an easy fix, just do it. But if there are things that are going to cause long-term problems with the project, with your maintainability, this is what our job is. This is where we this is where we matter. It's our responsibility. It's our responsibility as the software development team to take a step back and say, if we build this in the patch way, this will cost you a lot of money in the long run. And so our role is to be, I have it down here, the Lorax. The Lorax. It's the code can't speak for itself, right? The code won't tell anybody what's going on. And it's our job, it's our duty, it's our responsibility as the frontline programmers and the architects and everything to speak up on behalf of the code, because we're speaking up on behalf of the business 6 months from now or a year from now. What we have to do because if we make these compromises in the short term, and this is, how many times have you come back to your code and said, or you've opened Git and you said, "Who the hell programmed this?" And then you go, "Oh, it was me." Or you look back at your code, you say, "What the hell is going on here? I have no idea. Who wrote this stupid thing?" And you come back and you go, "Oh, it was me." Right? These are the things that we have to, and that's an individual code sample example. But in terms of the architecture of the entire system, we have to speak up for the code. And he has a sub chat. It's not a chapter, but it's a subsection within the chapter. This, if there's one thing you come away with, fight for the architecture. In the battle of structure versus behavior, it's always a struggle. As a developer, you are a stakeholder if you plan to be at that company or with that business or working with that client for years to come. The effort you put in to keep it in good shape now will pay dividends in the length of your career. Say it again. It is your duty to make sure it's maintainable code. The Staff Engineer book by Will Larson. I held that one up earlier. This one, highly recommended. I love this book. I've got to stop saying he has a spot in his foreword or his introduction where he refers to the senior most engineers as much like the Lorax, speaking for the code like the Lorax spoke for the trees. You would have to have read the Dr. Seuss book to know exactly what that reference means, but I did pull up a screenshot of the Lorax. I'm gonna Google for Lorax so we have Lorax. Show me the Lorax. Show me the Lorax. This guy. Well, here, just do this. Open a new tab. Open image in new tab. Open image. Here we go. Here, this guy's the Lorax. Hello, I'm the Lorax, here to speak for the trees. But again, you have to have read the book to know what that means, but it's a short book. Check it out. And what's the last thing? So in conclusion, if the architecture comes last, then the system will become impossible to continue developing on a reasonable budget. And so that is this week's entry in the Clean Architecture Book Club. And I hope that that was useful for you and interesting and entertaining to some extent. I don't know that this is necessarily have to be entertainment. When was the last time your professor at university was, CS50 was entertaining. Well, I'll get there one day, Harvard. Okay. Anyways, Sir Kruk, thank you so much for coming out and sticking around for the whole show. I really very entertaining. I really appreciate having you here. It makes it a lot easier because otherwise, if I don't have anybody in the chat, it's just me talking to myself, and I will do it anyways, but I'm just really, really thankful that you came. It was helpful. It kept me company, and I hope to see you next week. So, thank you. Okay, that's the end.